Layerwise Richardson extrapolation is a recently introduced strategy for quantum error mitigation. It generalizes zero-noise extrapolation, and in this video, we'll briefly discuss how the technique works and give a demonstration of how to use it in Mitiq. In zero-noise extrapolation, every layer of a circuit is folded either locally or globally. In layerwise Richardson extrapolation, every layer can be folded independently of one another. In this example, layer 1 is scaled by lambda 1, layer 2 is scaled by lambda 2, and layer 3 is scaled by lambda 3. The entire protocol for layerwise Richardson extrapolation can be seen by this diagram. The circuit of interests are scaled according to a vector of scale factors, and the circuits are then run and the results are collected. The results can then be combined into a new estimator for the expectation value of that observable, and here denoted OLRE. We can now walk through how to use this technique in Mitiq. I've defined a circuit of interest, here a simple one just so we can demonstrate, along with a method of running the circuit. Here we'll use a simple density matrix simulation with depolarizing noise. First, we can visualize the circuit. So see, we just have a Hadamard gate followed by a controlled NOT with the Z gate following. The first thing that we can do is see how Mitiq will generate the multiple noise scaled circuits. To do that, we have a function multivariate layer scaling, which will take the circuit of interest, along with two parameters, degree, which will give it 2, along with a fold multiplier. For simplicity, we'll just give this 1. So you can see many noise scaled circuits are returned. The first one being the circuit as we've defined it. The second one folds only the Hadamard gates. The third one folds only the C0 gates. Third, only the Z gates. Now we fold the Hadamard twice, where here we fold the Hadamard once and the C0 once. Here we fold the Hadamard and the Z, just the C0 twice, the C0 and the Z, and then just the Z twice. To run the entire protocol in one function call, use execute with LRE, which will take 4 things. First, the circuit of interest. Second, the way in which you'd like Mitiq to run the circuits. And then just like before, we have a degree, which we'll use the same parameters, and fold multiplier. You can see we get a 0.49. Now the ideal value, if we just run the circuit with noise level equal to 0, since this is just a GHZ circuit, will be 0.5. And if we run the circuit with noise, you can see 0.46. So we get a bump in performance, and all you had to do is add 1 line of code. If you'd like to learn more about layerwise Richardson extrapolation, visit mitiq.readthedocs.io to see our user guide for not just this technique but all the others. Here you can learn more about what individual parameters the functions take, along with what is some theory behind LRE.